Continue on with our factoring. First couple questions will be a little bit of review, but then we're going to start factoring some harder things. So, this one says, is x plus 3 a factor of each trinomial? There's two ways you can try. Way number one is you can factor that entire thing. And that would get you the right answer. You would either get x plus 3 or you get something else. But is there another trick that would be way easier? Yeah, the question is x plus 3 a trinomial? If you don't want to factor this entire thing to see if x plus 3 ends up as one of the factors, there's a really easy way to tell if it's a factor. Before that, even.
Just look at three numbers and x is like all three.
If you can divide x plus 3 out of all three things, that work, but that's going to be really hard. Dividing binomials into a trinomial is hard. What does a factor tell you? There's another word for factor is roots. What's another word for factors or roots? It's divisible by that. The other word is zeros. So a factor tells you your zeros. Meaning that if x were equal to negative 3, the whole thing would equal 0. Because when you break something into a factor, so we'll say x plus 3 times something, if this is a factor, that means if we put in negative 3, the whole thing will equal 0. So if you want to test if something's a factor, you just find what x has to be to make it 0. In this case, if x was minus 3, it would be 0. So let's test it. Take minus 3, and we'll sub it in here. So you have 4 times negative 3 squared plus 12 times negative 3 plus 9. This first part will be 4 times 9 plus 12 times negative 3 is negative 36 plus 9. 4 times 9, what is it? 36 minus 36, 0, plus 9 equals 9. So it doesn't work. That means it's not equal to 0, which means that isn't a factor. Because, that's a good question. X plus 3 is your factor. X plus 3. But what would make that entire binomial equal to 0? What value of x would make that whole thing 0? Negative 3. So if x were negative 3 here, it would make the whole thing 0. That's why I chose negative 3. So now if you ever get asked, is something a factor, you can actually solve it really, really fast rather than having to go through the whole factoring process.
So every time you on that,
yeah, and if it was x minus 3, you would change it to a positive.
Oh.
Okay, let's try this next one. Is x minus 3 a factor of the one on the right? You could factor the whole thing, or you could sub negative 3 in and test it. 2 times negative 3 squared plus negative 3 minus 15. That's 2 times 9. Plus negative 3 minus 15. That's 18 minus 18 equals 0. So if I'm right, if my theory is right, Emily, if my theory is right, then that's a factor. Put the phone away and please stop talking. Thank you. Let's see if my theory is actually right. Let's factor the one on the right. What goes on the top of your diamond? Negative 30. What goes on the bottom? 1. Numbers that multiply to be negative 30 and add to be 1. 6 and negative 5? Does that work? Okay, so our binomials, we're going to put 2x plus 6, and then 2x minus 5. But we have too many 2's, so we have to divide 2 out of one of these. Which one does 2 divide out of? The one on the left. So your final answer would be x plus 3 times 2x minus 5. So no longer do you have to do all that work to figure out if something's a factor. You can just find what makes something a 0 and then sub that in and see if it actually works. Remember we talked really briefly about these factors? They tell you things. Those factors tell you where your zeros are, where your x-intercepts. Another term for it. The x-intercepts would be at negative 3 and positive 5 over 2. That one's a little harder to figure out.
So if you get 0, you, like how we did that first time, you get 0, it should automatically know that it's a factor.
Right. So if you figure out what would make that 0, negative 3, if it makes the entire thing 0, then it is a factor. X plus 3 is the factor. So this is the factor, x plus 3. But the way we could tell it's a factor is because putting in negative 3 gave us a 0. I know that's a little complicating and a little bit conceptual. Yeah, so that doesn't tell us what the other factor is, right? We know there's another factor, we just don't know what it is. The only way to figure out the other factor is to actually factor. Ty.
Let's say that was like, instead of x, or 2x minus 5, 2x, 4, or 6, like a positive. How do you know which one then exactly?
So if this had been 2x plus 6,
Yeah.
and this had also been like 2x plus 6, which one to choose? It wouldn't matter. So if you could factor both of them, divide both of them by 2, you just pick one. Yeah, and you're good. That's likely a sign that you didn't take out your greatest common factor as your first step. Remember, your first step is always take out your greatest common factor. If you can divide something out of both, it means you didn't do a greatest common factor somewhere. Okay. Next one. Factor each trinomial. If you look at this, and we try diamond method, what goes on the top of your diamond for this question? Negative 1.2. What goes on the bottom of this one? 1.4. Who in this room feels comfortable finding things that multiply to be 1.2 and add to be 1.4? I'm not on that list. Yeah. That's going to be really hard. Any ideas?
There's some easy math to
Yeah. So Josh's suggestion is just make it like 12 and 14. That works perfect. So you can't just change things though, right? So when we talk about making it 12 and 14, what are you really doing? Like moving the decimal place over 1, you're multiplying by 10. So Josh's idea is great. Let's multiply everything by 10. Because then we have numbers we can actually work with. Yeah, we can actually do that. So we have 10x squared plus, yeah, we don't need that diamond for now. So we've multiplied everything by 10. Now those are numbers we can actually work with. But Maddie is saying, can we actually do that? And her instincts are right that you can't just multiply things by 10. You have to also divide by 10. Because you can only do things by 1. Remember, you can multiply by 1, you can divide by 1. It doesn't change your answer. So if at the outside you put brackets, 1 over 10. So you remember to divide by 10 at the end. Now we haven't changed our equation at all. We've just made the numbers look better to us. That's all we've done. Now let's factor the inside. What's the first thing you always want to check? Greatest common factor. What's the greatest common factor we can take out of all 3 of those numbers? 2. So factor 2 out of all of those things. And it'll come outside the brackets on top of that 10. Yeah, so it becomes 2 out of 10. Because when you're multiplying fractions with other numbers, the numerators multiply and the denominators multiply. And factoring out a 2 is like factoring out a 2 over 1. 2 multiplies on top, 1 multiplies on the bottom. So, yeah, you can simplify that to be 1 over 5. 2 divided by 10 is just 1 over 5. All of our other numbers simplify quite easy. 5, 7, 6. Now it's just a trinomial that we're used to working with. Anytime you guys are factoring trinomials, your goal is to get into something that looks familiar. As familiar as possible, anyway. This is familiar. Diamond method, the inside. What goes on top of our diamond? Negative 30. What goes on the bottom?
Negative 60. Or yeah, no, okay.
Negative 30 on the top. Plus 7 on the bottom. What are our 2 side numbers going to be? 10 and negative 3. So now you break up your trinomial into your 2 binomials. One of them is 5x plus 10. The other one is 5x minus 3. And in front of all that is still your 1/5. Remember, that's 2 over 10. That's the same thing. 1 over 5 and 2 over 10 is the same thing. Can I divide my 5 out of 1? Okay, let's look back at this step, because I've lost some people. So, on the inside, the trinomial, the 3 things inside, I factored them using my diamond method. I got 10 and negative 3. So my 10 and my negative 3 came down here. Plus 10, negative 3. And remember, I had to pick 5x. Because I know that at the end, I wanted 5x squared. So I had to have 5x in each of these. And then the front number, this 1 over 5 right here, that came from 2 over 10. Those are the same thing. 2 over 10 is 1 over 5. I've just reduced it. That's all I've done. Any questions? Nope. Okay, if we have 2, 5, we have a 5x and a 5x, and we know that's too many, right? So we have to divide 5x out of one of them. Which one does that 5x divide out of? The first one. So the first one we're going to divide by 5. And it becomes just 1 plus 2. So your final answer is 1/5 times x plus 2 times 5x minus 3. That's your final answer. Don't multiply the 1/5 back in. No. You could if you wanted to, but you're just going to change everything back to nasty decimals. So there's no point. Gainer. Oh yeah. This is where we're headed, guys.
That's how it's gonna appear.
Yeah. That's how your final form will look on the test. Dante. Just wait, guys. Dante's got a question. If you have a question, you can ask him too when it's your turn. Go ahead, Dante.
Yeah, I was going to ask, if they give you a question on the test and it has decimals, can you convert it to whole numbers? I don't even want you to put your answer next.
Yeah, leave it as a fraction. It'll always say decimals or fractions. If it doesn't say, leave it as a fraction. But the way that, yes. So if you like to do it the way that you divide by 5 right here, and then you just make it x plus 2, that's the same thing. We're just doing it at different steps. So if you're doing it that way, that's good. Keep doing it that way. Just 2 different ways of doing it. You do you, kid. Okay. Let's look at the B, because B is even harder. If you're looking at B, we have a fraction on that second one. Fractions suck. So what can we do to fix that B value? Multiply everything by 2. But you can't just multiply things by 2. So you have to also divide by 2. So we're going to multiply every term by 2 in here. But then we're also going to put in brackets on the outside, 1 over 2. So like this, like 6x squared minus 29x plus 14, like that?
28.
Yeah.
Like the final answer?
Yeah. That's a good question. So, Gator's question is, can you not just divide by 2 at the very end? And yeah, you could. So if you just multiply by 2 now, and then at the final answer, remember to divide by 2, or multiply by a half. Yeah, you could do that. The only place you're going to get in trouble is those questions that are like, find the mistake, will always be written the way that I'm doing it. Because you're supposed to, in math, always keep your steps completely equal. Right? We're going to go over that here. Yeah. We still have people writing it. And I'll show you an easy trick for those questions. Okay. I multiplied everything by 2. We're going to multiply it by a half as well so that it's balanced.
For example, if you're going to, instead of multiplying by 2, if you're going to multiply by 3, then you just put the 1 over 3, or 1 over 3.
Yeah.
So whatever you're multiplying by will just be 1 over 1.
Exactly. Yeah. So whatever you're multiplying by, you're doing 1 over that same number. Hi.
So it's like, what do you do with the radicals? It's not radicals, but when you have like fraction product, that by 2 you cancel it out.
Right. So,
But you still break the shit.
like at the very end,
Like, you put 1 over 2 to show that you multiply by 2.
I'm putting 1 over 2 because you're only allowed to multiply things by 1. You're not allowed to change things. So right now, even though it looks different, we haven't changed this equation. All we did was we multiplied it by 2 over 2, which is just 1. And multiplying anything by 1 doesn't change it. We've just represented it and distributed the 2 in. And the 1/2 has to stay out. It has to stay there. It stays there as a good reminder that you multiplied by 2. But the reason we did it is because it has to balance out. No? Okay, ask again. Ask the question. Ask the question again.
Okay.
Because there's no way you're alone. There's a lot of people looking at me like I'm crazy.
So, okay, I gotta change because the 2's throwing me off right now.
Okay.
Okay. Would it be the same? Would it be the same thing? You multiply you're not multiplying everything. That's what you're saying that you are. Like.
Yeah, I'm multiplying.
Yeah, it's just rationalizing.
It's the exact same thing. Yeah.
That's what I was
Yeah.
asking.
We don't call it rationalizing because we're not rationalizing a denominator. That's like a term for radicals. Like that's a radical term. Same concept though, yeah. It's just that you're doing fractions to get rid of the fraction on the bottom. Yeah. Okay, that makes sense now? Okay. Now we have something we can work with. What's your first step? Your first step is what? Common factor. Is there a greatest common factor? No. No greatest common factor. So what's your next step? Yeah. Diamond method it. What goes on the top of the diamond?
168.
What goes on the bottom?
-26.
What goes on the sides of the diamond?
-21 and -8.
Thanks for that, easy. Thank you. You get -21 on the left, -8 on the right. Those are your two factors. So, we're going to go 6x minus 21 times 6x minus 8. We can't have two 6's, so we have to divide one of these by 6. Neither one divides by 6. So you need to divide one of them by 2 and the other one by 3, because 2 times 3 is 6. We're just breaking that 6 up over two things. Which one divides by 2? Second one. Which one divides by 3? Yeah. What am I forgetting right now? The 1/2 out front. So your final answer would be 1/2 2x minus 7 times 3x minus 4. Yes. So you can take everything in the brackets right now and write it over 2. That'd be the same answer, yeah. So you'd be good getting it.
Or you can also do like 1 or 0.5x or no, it's 1.5x minus 2x.
Yeah.
2.
Yeah. You could do that too. Are we good? Try these two on your own. Go. So, the first one, I multiplied by 10. The reason I multiplied by 10 is 10 is a really easy number to multiply by. I know that I'm just going to move the decimal 1 over. If you want to multiply by 2, that works, because it'll get rid of all your half or your 0.5s. I multiplied by 10, which means I had to divide by 10 as well out front, so that's my 1/10 out front. I looked at this, I took out my greatest common factor of 5. The 5 came out front. 5 divided by 10 is just 1/2. That's where that 1/2 out front came from. If you had multiplied by 2, this is the step you'd already be at. On the inside, I have 2x squared minus 3x plus 1. I diamond methoded it over here on the right. Positive 2 on the bottom, negative 3 on, or positive 2 on the top, negative 3 on the bottom. Two numbers that multiply to be positive 2 and add to be negative 3 are negative 2 and negative 1. So I wrote those as my factors. I had 2x minus 2 times 2x minus 1. I knew that I had to take out a 2 out of one of those, because I can't have 2x times 2x. That wouldn't make sense. The 2 comes out of the first binomial quite nicely, so that's what I did, and that's your final answer. Any questions on that one? Okay, try B on your own. I'll run us through it. If you have questions, you can put your hand up. I multiplied everything by 3 because my second one was a fraction of 17 over 3. And I know I can cancel out that 3 by just multiplying by 3. So that's what I did. 1/3 out front, multiplied everything else by 3. Things that multiply to be negative 18, add to be negative 17 in my diamond. Negative 18 and 1. So I broke it up into negative 18 and 1. I knew 3x was too many, so I had to divide one of them by 3. I divided the first one by 3. And then I ended up with 1/3 x minus 6, 3x plus 1. If you have a question, ask. Time.
Where's that again?
Where's which?
How?
Which step?
Did you get rid of the x? Or give it step 2. How did the 17 change to 18?
From the diamond.
Diamond method. This was a trinomial. I used diamond method to get 2 binomials.
Oh, okay. So where did Oh, okay. 17's the middle.
Yes.
Okay.
Next question. Okay. If you look at 2.3a, we have x squared minus 6x minus 16. That looks pretty nice, eh? We can easily diamond method that one. You'll get negative 16 on the top. You have negative 6 on the bottom. 2 things that multiply to be 16 add to be negative 6. Negative 8, 2. That's your answer. If you get a question like that, easiest question of your life. Now, if we look at B, again, we have a question that looks really terrifying. Much like the last ones look scary because they had decimals and they had fractions and stuff like that. So we want a way to make this easier. London, any ideas? Exactly. So if you look at this question right here, look at this question. I'm going to circle everything that's the same from the question above it. The 2 is the same as the 2. The negative 6 is the same as the negative 6. And the minus 16 is the same as the minus 16. Those things are all the same. The only thing that's different is x has changed to x plus 3. That's the only thing they've done different, is they made x equal to x plus 3. That's the only difference. So you could literally take your answer from the first one and change x to x plus 3. And that would be your answer. So right now, if you take this first answer, and everywhere you see x, change it to x plus 3. So your answer now becomes x plus 3 plus 2 times x plus 3 minus 8. That's the exact same thing. All I did was I changed x to x plus 3, the same thing that they did in the question. They changed x to x plus 3. 3 plus 2 is 5, so x plus 5. And 3 minus 8 is x minus 5. Those would be your factors for that ugly equation in B.
What happens if you get an awesome question that looks like that?
Yeah. So the point that we're trying to make here is you're never going to get back-to-back questions like this.
Exactly.
So all you need to do is change this x plus 3 to x yourself. And then factor it, and then put it back in. Yeah. The negative 16 is just fine on its own. I'll show you guys a question. Look at this ugly old equation. Terrible. Not pretty at all. But if we take this part right here that looks so ugly, 3x minus 4 and 3x minus 4, and we change those both to x, the question's not hard at all. If we made this 6x squared minus 21x plus 15, that's no longer a scary question, is it? Every time you're factoring a trinomial, change it to something that's easy. The way we change this to be something easy is we said x is equal to 3x minus 4. We sub that x in, and then we solved it after. And in all honesty, I'm using poor terminology here. You shouldn't say x is equal to 3x minus 4. You should say something like z is equal to 3x minus 4. You can't have x on both sides. So that's kind of faulty language, but I'm leaving it as x because that's what we're so used to right now. That you guys are so good with x, I'm just going to leave it as x for now. But in the future, I'm going to start saying z. So don't be freaked out when that happens.
There's like a written and then good x plus this. There's a good form.
No, you'd be fine. The variable wouldn't be the part of the mess yet. Right, so I would say this. I would say z is equal to 3x minus 4. And I would put that as a z. Like this. And that's technically better terminology, but at the end of the day, I care more about being able to do the math. It's a problem with terminology. We can always fix terminology after. All that really matters is the math. Okay, let's factor this thing. Diamond method. It's a trinomial. Oh yeah, take a 3 out. Greatest common factor. Good catch, folks. 3 out. You have 2z squared minus 7z plus 5. Yeah. Change it to something you're used to seeing. That's always going to be the trick. Whether it means you're multiplying things or summing things in, that's always going to be the trick. Change it to something that looks familiar. The top of this diamond is a 10. The bottom is a negative 7. Negative 5 and negative 2. So that's what I'm going to change my trinomial to. It's going to be 2 binomials. It's going to be 2z minus 5 times 2z minus 2. Too many 2z's, so I have to divide one of them by 2. The one on the right divides nicely. So I'm going to divide it 2 out of both of those. And then I have 3 times 2z minus 5 times z minus 1. But you're not done. You have to put this weird equation back in for z now. So in your factors, you're going to substitute 3x minus 4 in. So your first factor, I'm going to erase my diamond over here. Your first factor is going to be 2, and put it in red so it sticks out. 3x minus 4 minus 5. That's my first binomial. So I took my z and I substitute 3x minus 4 back in for it, and I use brackets. That's critical. Your next trinomial is just going to be x minus 4. Sorry, 3x minus 4 minus 1. The reason brackets are so important is this 2, the one I'm going to underline in blue. This 2 needs to multiply into the brackets before you can simplify. So it's going to multiply, multiply. So out front, still a 3. Now we have 6x minus 8, and then we still have minus 5. That's our first binomial. The second one is easy to simplify. The 3x is still going to be 3x, minus 4, and the minus 1 can combine together to be minus 5. 3x minus 5. The first binomial can still simplify. How can it simplify? The 8 and the 5 can combine together to be minus 13. So you have 3 times 6x minus 13 times 3x minus 5. And you can see factoring is getting harder, but it's really not getting much harder. We change it to be something easy, and we change it back. The factoring never gets harder. It's just what you're doing to be able to factor that makes it harder. The factoring is still same old diamond method. Nothing crazy is happening. These are the type of factoring that you're going to get. Does anybody have a question on this one? Now is a perfect time to ask. Put a hand up so I know who's asking the question. Yeah, Calvin. That's a great question. And a lot of you were doing that earlier in our last unit. If you look over here, I'm going to circle it in green. That -1. That's a binomial minus 1. That's not multiplied by minus 1. If you're multiplying something, the coefficient will go on the front of the binomial. If it's on the back of the binomial like this is, that's subtraction. So it's not a -1 multiplying in. Exactly, yeah. Solve everything in the brackets that you can. If you can't solve any more, then the brackets kind of dissipate. Soccer. That's our answer. Is it different? This question, you would get 1 mark for substituting in a different variable. You get a 2nd mark for factoring properly. That'd bring it here. You'd get a 3rd mark for summing back in, and probably a 4th mark for simplifying it out. So this is probably a 4-mark question. Potentially 3 marks. Potentially this last 2 steps is just 1 mark. The summing back in and the simplifying. That's pretty much a 1-step thing. You can do it pretty quick on most questions. Depends on the question. Okay. On the top one, we have an easy trinomial. Things that multiply to be -24 and add to be 5. 8 and -3. So your answer to this top one is x plus 8, x minus 3. Those are easy. We want to change hard questions to look like easy questions. So if we look at B, that's a hard question. How can we make it an easy question? Calvin, yeah? What do you want to do? Take out the x minus 6, because that's what makes it so hard. What are we going to put in for x minus 6? Z. We'll use Z. My J's look ugly. My Z's aren't pretty either, but at least you can tell there's Z. Make Z equal to x minus 6. If you change these things to Z, it's a pretty easy thing to do. What's the first step always? Logan knows. Take out your greatest common factor. There's a 2 in all of these. 2 on the outside, then you're left with z squared plus 10z minus 24.
Wouldn't it be 5z?
Sorry, it is 5z. Things that multiply to be negative 24 and add to be 5. It's the same as the question before, yeah. Plus 8 and negative 3. So we're going to change it into 2 times z plus 8 times z minus 3. But we're not done. We change our z back to our x minus 6. Oh, we're going to get 8. If we diamond method this, the top of the diamond would be negative 24 on the top, 5 on the bottom. Things that multiply to be 24, 8, 3. Negative 8, positive 3. We're not done though. We have to sub our x minus 6 back in for z. So it becomes 2 x minus 6 plus 8 x minus 6 minus 3. Do everything inside the brackets you can, and the brackets go away. So x minus 6, nothing we can do inside those brackets, nothing needs to be distributed in. So the brackets go away. Negative 6 plus 8 is positive 2. So we get 2 times x plus 2. The next one, same thing happens, x minus 9. That's your final answer. That?
2.
Probably 3. 1 for subbing that in, 2 for factoring, 3 for subbing it back in. Subbing in the x minus 6, it's still high. If you can make hard things look easy, it's way better for you. Look at this next one. How are we going to make this hard thing look easy? Change 2x plus 5 to z. Do it on your own. Okay, so if we're doing this question, it looked difficult till we changed 2x plus 5 to a z, and then it's just the same old trinomial. And I factored it using my diamond method. Negative 24 on the top, 10 on the bottom. That's negative 2 times 12. So that's what I made my binomials. I knew I had too many 3's, so I had to divide 3 out of one of them. I chose the first binomial because it divided evenly. That gave me z plus 4 times 3z minus 2. Your answer doesn't, z doesn't work. I have to change it back to x's. So I subbed my 2x plus 5 back in for z, and then I simplified. Your final answer should be 2x plus 9 times 6x plus 13. Any questions?
I really don't have to use that.
No, do whatever letter you want. Just don't choose x. In all honesty, I'm not going to dock you marks for using x. I'm not. The reason why you can't use x, if it had a y or an a or something like that, then you could pick x. Yeah. You just can't pick the same variable. It just doesn't make sense. Because if you look back at like what you're saying when you're subbing something in, is you're saying x is equal to 2x plus 5, which doesn't make sense. If you chose the x to be 2, 2 is not equal to 9. Like that doesn't make sense, right? And I'm not going to dock you marks. I'm not. So if you're using X, that's fine at the end of the day. The other perk of using a different letter is it'll remind you that you have to sub in at the end. Like if you have an answer in terms of Z, then you obviously forgot to change it back to X. If you go to university and do any of these courses, they will make you use a different letter, and they will dock you marks. At the end of the day, I don't really care as long as you're understanding how to do that. That's what matters. The technicalities to it, who really cares? Yeah, it's just gonna happen.
I'm sorry you came up with the theory of relativity, but you did it wrong. Like you should have done it doing it this way.
Yeah.
But
Same old. Okay. If you're looking at A, what do we have? We have a difference of squares. We have something that's you can square root, and we have another thing you can square root, and they're subtracted. So that means we can change it to be x minus y times x plus y. With that one? Okay. Yeah. If you look at a binomial and it's telling you to factor, it's probably a difference of squares. Mine.
Isn't B equal?
yeah.
Is it what?
No, it's just
No. No, if we look at B, just wait. What?
For B, would it just be 2x minus 1 and then like times 2x plus 1 minus y?
That's a good question. So, if you look at B, and they tell you to factor B. That looks hard. Change it to be something easy. We don't have the same thing and the same thing, do we? No. So choose two different variables. Make A equal to 2x minus 1 and make B equal to y plus 4. And now what you have is A squared minus B squared. Now you have something that's easy. A squared minus B squared is obviously a difference of squares. So do the difference of squares. It'll change to A minus B times A plus B. But our answer isn't in terms of A's and B's, it needs to be in terms of X's and Y's, like the question originally was. So change your A back to 2x minus 1, and change your B's back to y plus 4, and use brackets every time you substitute. So I'm going to have 2x minus 1 in brackets, minus y plus 4 in brackets, and then we're going to times it by, and it's going to get a little messy. I'm going to write it over here on the left, right next to it. 2x minus 1, y plus 4. I've just reversed the two sides of it because it got messy. The reason we use brackets is pretty important. That negative has to be distributed into the brackets. No. Using brackets is important. That minus has to distribute in. Right here. Has to. Don't forget to do that. The first one's going to simplify nicely. It's going to be 2x plus y plus 3. The other one is going to be 2x minus y minus 5. If you don't distribute your negative a, your answer is going to be wrong. That's your final answer. Remember, you always check at the end if you can take out a greatest common factor. And you can. So you're good. This is another one that looks hard. But it's really not if you break it down. What's the first thing you always want to do? Make things simple. Change the x plus 2 to be a. Change the 2y minus 3 to be b. Now it's simple. What's the next thing you always do? Greatest common factor. What's the greatest common factor you can take out of both of these? It's not 6. It's not 4. It's not 2. It's 2. Divide both those by 2. If you didn't divide both these things by 2, they're not a difference of squares. You can't square root 32 and you can't square root 18. So that's actually probably the most important step. Now you have a difference of squares. You can square root that first thing, you can square root that second thing. It should change to be 2 times 4a minus 3b times 4a plus 3b. But our answer can't be in terms of a's, b's, because our question was in terms of x's and y's. So you sub those numbers back in. It becomes 2 times 4x plus 8. All I did was I distributed the 4 in my x plus 2. And then minus 6y plus 9. All I did was I distributed my negative 3 into what b was. My other one is going to be the exact same. It's just going to be all of, like, these two symbols will change. So it'll be 4x plus 8 plus 6y minus them. Notice that those are the same thing, it's just the last one symbols change. The 6y came from negative 3, and I changed it to 2y minus 3. That's my b, and I distributed the negative 3 into both things. So it became negative 6y plus 9. I was just doing some steps quickly. Your final answer would be that simplified. So bring the 8 and the 9 together, and the 8 and the 9 together. I try to show you guys work where I skip some steps and do them in one, because when you see questions done on tests, they'll be like, where's the mistake? And that's what they're going to do. They're going to jam multiple steps into one, because they expect that you should be able to do that. Okay, you guys can move your seats back. Has everybody written our last unit test except for the one person I spoke to already?